using the database relation. So there have been some work on handle analysis for JavaScript programs, and most related ones include Actors. Actors is a static handle analysis, and it gives a code graph. Code graph construction is complicated for object-oriented programs, and also especially for JavaScript. And Actors then traverse the code graph to find the sources, sinkers, and sanitizers in the code, and then detect potential vulnerability. So if there is a path from source to a sink that does not pass through a sanitizer, then the information that ends up with the sink is considered handy. Gatekeeper is another static analysis. It is mostly static analysis. What Gatekeeper does is to express properties of web application or JavaScript application as a data node query, and also express programs as a data node program. And then, of course, the query is checked against with the program to do the analysis. There's another piece of work presented by Wright and Wei, which combines static and dynamic approaches. So there are two phases during the process. In the dynamic phase, the web application is test run, and then some information is collected on the test web page. And then this information is used to construct a representation of the program, and then a static analysis is run on the representation of the program. Of course, this is an opportunistic approach because it does not analyze the program for all possible runs. So it just run the program for a superset of the runs that is connected in the dynamic phase. Well, what we have noticed is that in this previous work, they don't distinguish between different rendering HTML contexts. And also they use a constant propagation domain to track strings, which gives a very coarse analysis. There are 6 different HTML contexts that can be reached from a JavaScript execution context through DOM-based methods. And these methods are illustrated on this slide. And HTML attribute context includes all the locations into which an HTML attribute can be accessed, except for the event handler attributes, and also URL attribute contexts. HTML event handler attributes actually represent actions that the web page takes. When, for example, here, when when a web page is clicked, then some application is run or some action is involved in this web page. And also, UI attribute context represents those contexts where UI can be written into. And CSS attribute context basically represents the style of the presentation. But in each context, actually requires different encoding mechanisms. Object web page OWASP is object open access. Let me see. What is that? My brain is not working properly, so I have to. Okay, WASP represents stands for Open Web Application Security Project. They recommend 3 different encoding mechanisms, and these are JavaScript encoding, HTML encoding, and URL encoding. And also they recommend different encoding applied to different contexts. For example, for HTML event handling context, and that will require 2 different encodings to be applied. One is JavaScript encoding, and another is HTML encoding. But for JavaScript context and event handling context, the primary recommendation by them is that to avoid putting user input into them, because the encoding might not mitigate against the DOM-based cross-site scripting. So we always consider tainted data ending up in those contexts are not safe. So here's an example of application. So this encoder URL encodes the data for URL context. But this encoding method does not encode the single quotation mark. So this, I cannot, sorry about that. That encoder URL function does not encode the data properly in this context, because single quotation mark is not encoded. So the user can still, for example, attack the attacker can still construct the data URL input that can cause the web page exceed the attribute, and then insert a new URL link into the web page. But on the other hand, for this inner HTML attribute, here there are 2 encodings. Those are sufficient according to OWASP's recommendation. Well, our work is horseback down another project that is called TAJS, called Type Analysis for JavaScript programs. And TAJS is context-sensitive analyzer for JavaScript that supports ECMA script language, and also DOM, and it mainly infers type information. It can tell us the types of variables, of values of a variable can take. This is important because JavaScript is not a statically typed language. So you can change the type of a variable dynamically. And this analysis is based on monotone framework using a lattice structure. The lattice structure is quite complex, but this lattice is based on constant propagation domains for primitive data types. So there's a constant propagation domain for strings, for Booleans, another one for Boolean, another one for floating point number, etc. So the result of our work is analyze we call TAJS Taint, because what we have done is just to add Taint analysis to that analysis. To do that, we have to add an abstract domain for Taint analysis, and also we have to modify string analysis provided by TAJS. So TAJS Taint allows rules of these forms. Okay. Each rule is a triple. The first element of the triple is the source, and the third one is the sink, and in the middle there's a set of sanitizers. Here's an example. Okay, so for example, the source can be document.url location.ref. 5 minutes? Okay. I will finish in 5 minutes, okay? And the sink is document write, and then because this document write requires two different encoding mechanisms. One is called JavaScript encoding, and another is HTML encoding. So our domain basically tracks values of variables. We track what kind of encodings this value has undergone. So the abstract element, we have three. One is HTML encoded, another is JavaScript encoded, and another is URL encoded. The meaning of these are pretty obvious. And the domain is a power set of this domain T and ordered by superset inclusion. Because the more encoding a value has gone through, the more strict the type is. So here's a Gava. This is a concretization function, and it induces a Gava connection. And also we, as I mentioned, that we modified the TAJS's string analysis. So for each variable we attach, for each string variable, we attach deterministic finite automaton to track the set of strings this variable can take. So this is more precise than TAJS's original type analysis. So here's this shows the difference. Let's say we have this lookup function. You can see that the lookup function actually looks for properties that have the form GN1. But if we use constant propagation analysis, we will know all the information. So all the properties can be looked up in the original TAJS. But in our analysis, we only look up the properties, names that begins with G's followed by 1. We implemented this analyzer, and we did some experiments. We selected benchmarkers from the Annexa project that hosts the real websites. And then we found some errors with existing websites. But I guess we are not in order to disclose the names of these websites because those are websites that are in use. So we use symbols here. So in the second column, those are true positives. So those are locations with encoding problems. And in the third column, those are numbers of improper encodings that have been detected by our analyzer. So we basically, for those specific benchmark programs, our analyzer actually discovered most improper encodings. But of course, there are some applications, for example, application D, there's 3 true positives. Our analysis only discovered 2. Execution time-wise, we think our analysis is practical because it does not require too much time. I want to point out that most of the time is spent on that string analysis.
Which computer? I mean, 5 seconds is for some real laptop?
No, it's
Desktop?
yeah, it's described in the paper, but I cannot remember. Yeah, desktop, yeah. Desktop PCs. So in conclusion, we presented a new analysis for JavaScript programs for detection of DOM-based cross-site scripting vulnerability. So basically, we distinguish between different rendering contexts. We build that context information into our analyzer, and also we use a more precise property domain for string analysis. The result, of course, that this new analyzer can detect DOM-based cross-site scripting vulnerability more precisely than previous approaches. That's my presentation. Thank you.